Okay, the first thing we're doing this time is zero exponents, meaning if you have x, the base x raised to the 0 power, what is that? And I must also state that x is not allowed to be 0 because you can't raise 0 to the 0 power. You can raise other numbers to the 0 power, but not 0. So to explain what x to the 0 is, I'm going to go back to division. So when I explained the division rule, we said that if we are dividing like bases, then we subtract their exponents. And this is in general true for any situation. But what if m equals n? What if m is not greater than n, but actually is the same value as n? Well, if m equals n, then I can make a substitution here. I can say that this is equivalent to x to the m over x to the m. Something over itself, right? And we already know that anything over itself is 1. But we also know that because of the division rule of exponents, that x to the m over x to the m is x to the m minus m, or x to 0. Therefore, by transitive property, I'll do it here, x to the 0 equals 1. No matter what x is, as long as x is not 0. So anything to the 0 power is 1. You replace that x with anything other than 0, it's going to be 1. You replace it with a number other than 0, it'll be 1. You replace it with a very bulky term, raise it to 0 power, it'll be 1. You replace it with something in parentheses, maybe something long. If it's raised to 0 power, it's still 1. Now, negative exponents. We also said in the division rule that if n is bigger than m, this becomes 1 over x to the m minus m. That has not changed. That is true. However, you can also say that x to the m over x to the n is x to the m minus n, even if n is bigger than m. I didn't state this before in the previous video, but you can do that. However, if you do that, this number here, that will be negative, right? Because n is bigger than m. Well, now that we know that that is going to be negative, and we have this from the division rule, we know that these two are the same. So x to the m minus n, which is a negative number, is the same as 1 over x to the n minus m, which is going to be a positive number. So for example, x to the negative 3 is 1 over x to the third. This is what the negative exponent does. It's an instruction that tells you to take this base, put it in the denominator, and then change the exponent to positive. It's an instruction. It does not tell you, what does it not tell you? It does not tell you to make any part of this fraction negative. You don't see any negative signs here. That negative has a different function than a normal negative sign. That negative in this scenario simply tells you to put something somewhere down there. Take it back a step, how we would get something like this. If we had x to the 5th over x to the 10th, you could use the division rule and do 5 minus 10 for the exponent and get a new exponent of -5. And then change that to 1 over x to the 5th. So now we have a series of baby steps that we can take to get from here to there. Okay. You can use the old division rule and go straight from here to there too if you want. That's fine. Okay, so here's some examples. Okay, in number 1 here, I'm just going to use the the multiplication of like bases rule, first law, and I will add the exponents 3 and -5 because those are the exponents of x, and I get x to the -2, and then followed by y to the 6th. Now I'm not allowed to leave the expression in this form because when we simplify expressions with exponents, we are not allowed to leave any negative exponents. So I take that a step further using my negative exponent rule, and change the x to the -2 to 1 over x squared times y to the 6th, and then make it one fraction, y to the 6th over x squared. In number 2, again, I'll use the multiplication of like bases to add these exponents. And then the -1 and there's a 1 here, gives me y to the 0. The y to the 0 just becomes 1, so you can just forget about it. And then this becomes 1 over x to the 6th. In number 3, this is power of a product, so every single one of these bases gets raised to the second power. -3 to the second power, 9. X to the -3 to the second power, we multiply the exponents, x to the -6. Y to the -5, raise to the second power, y to the -10. I can't leave negative exponents, so 9 stays in the top, x to the 6th in the bottom, y to the 10th in the bottom. Number 4, power of a product again. Careful, the outside exponent is a -2. So 2 to the -2, x to the -4, y to the +6. I can't leave negative exponents, so I keep going. This becomes 1 over 2 squared. This is 1 over x to the 4th. This is just y6. And then I combine it into one fraction. Now the last one, this is one big fraction, so I use my division rule on the x's, on the y's, and on the z's. And I'm just going to use straight subtraction. Top exponent minus bottom one. So 4 minus negative 3 is 7. Negative 5 minus 2 is negative 7. And 2 minus 6 is negative 4. I can't leave my negative exponents, so I change y to the 7th to 1 over y to the 7th. I change z to negative 4 to 1 over z to the 4th. Alright, so there you have it, 0 exponents and negative exponents.